This is the second half of the November 16 paper 1. So question 9. Circle the correct answer for each of the following statements. 9 to the power of minus a half is equal to. So when we've got to the power of a half, that means square root. So you'd have the square root. Pen is giant. So we'd have the square root of 9. And to the minus means 1 over. So we'd have 1 over the square root of 9. Square root of 9 is 3. So it's 1 over 3, which is 1/3. 8 to the power of 2/3. This means the cube root of 8 squared. So the cube root of 8 is 2, and 2 squared is 4. So our answer is 4. The radius of a hemisphere and the radius of a cylinder are equal. The hemisphere and cylinder have equal volumes. Calculate the ratio of the height of the cylinder to the radius of the height of the cylinder to the radius of the cylinder. So if we look back at our formula list, you should know that a cylinder, just a normal cylinder, would be pi times your radius squared times your height. So that's your cylinder. And your sphere is 4/3 pi r cubed. And obviously we've got hemisphere, so we've got half of that. So we would just half 4/3 pi r cubed. In relation, we can get rid of both pi's. So we can get rid of both pi's, and we can get rid of 2 r's. So on our sphere side, we would just be left with a half of 4/3 of r compared to your height. A half of 4/3, just times the tops times the bottom, that's 4/6, or 2/3 of r would be your height. So compared to your radius, if the height was 1, the radius then would be 2/3. So your height being 1, your radius being 2/3. Or if you don't want it, you can keep it like that, or if you don't want it in a fraction, it could be 2 to 3, if we would times them both by. Question 11. Given that y is inversely proportional to x, and that y is 4 when x is 3, find an expression in terms of y in terms of x. So when something's inversely proportionate to something, it means that as one increases, the other decreases. So y would be our constant over x, and then to find out your k when it's inversely, we just multiply our x and y. So 4 times, I almost wrote y then. 4 times 3, which is 12. So our formula would be y equals 12 over x. Use the expression found in part A to complete the following table. So with our with this first box, so we keep your equation, you've got y equals 12 over x. In this case, x is 0.25, so you've got y equals 12 divided by 0.25. How many 0.25s go into 12? It's 48. Because if you know 4 go into 1, you just want to do 4 lots of 12. In this case, again, our formula, y equals 12 over x. This time, y equals a fifth, so you've got a fifth equals 12 over x. So to find out x, we just need to do 12 divided by a fifth, which is 60. You can see it makes sense because as one increases, the other decreases. Okay, question 12. Express 3x over 3x plus 2, take away 2x over 2x plus 7 as a single fraction in its simplest form. So to manipulate fractions, you need your denominators the same. So we want to multiply all of this first fraction by 2x plus 7. And you want to multiply all of this second fraction by 3x plus 2. It might help you to use brackets everywhere. So put brackets and you might not get confused. Put brackets around the top ones if you want as well. So I'm just going to multiply the first one. So I've got the top is 3x. I would multiply that by 2x plus 7. And the bottom, if I leave it in brackets, you don't have to expand the brackets out. So you've got 3x plus 2, and I would have all that multiplied by 2x plus 7. And I'm subtracting. I'm doing my second fraction. So you've got 2x times 3x plus 2 all over, so let's put a bracket over there, 2x plus 7 times 3x plus 2. You can now see your denominators are the same, so you can put all of the top into together and keep your denominators as 3x plus 2 and 2x plus 7. So I'm just going to expand my top now. I'm going to do 3x times 2x, that's 6x squared. Then I'm going to do 3x times 7, that's 21x. going to need to be a little bit bigger. So I'm subtracting 2 times 3x, so subtract 6x squared, and then 2x times 2, so that is, oh, I wouldn't put plus either. I would keep that as a minus because you've got to take it away. So we've got minus 4x. Simplify again. So the 6, this 6x, take away 6x squared would just cancel each other out. So you've just got 21x, take away 4x, which is 17x. And the denominator stays as it is. You can expand them if you want, but you do not have to. And that's our answer. Right, question 13. We've got points P, Q and R lie on the circumference of the circle, centre 0. PQ is the diameter of the circle, therefore the opposite is 90 degrees. A straight line ARB is a tangent to the circle, that for they've got a alternate segment theorem there. QRB equals x, where x is measured in degrees. Calculate the size of P, Q, R in terms of x. So without writing anything yet, you should know that because this is our diameter, this has to be 90 degrees. So you've got to explain that in your answer in a minute. Because this is x, alternate segment theorem says that this is therefore also x. Therefore, you should be able to find out Q by doing 180, take away 90, take away your x. So you just want to briefly explain that. So we can say, let's first say that RPQ is x as alternate segment theory. So that's why this one is x. Also QRP is 90 as it's a semicircle. And we've got the diameter obviously. Therefore PQR would be 180, take away 90, take away x, which can abbreviate to 90, take away x. So there's actually not much working out, it's just you need to know your circle theorems. Question 14. Alid has 3 concrete slabs. 2 of the slabs are square with each side length x. The third slab is rectangular, measured 1 metre by x plus 1 metres. The 3 concrete slabs cover an area of 7 metres squared. Show that. Right, they love to do questions like this. We did it literally today. So you've just got to prove that that is the case. So if I was just to visualise it, you've got 2 squares, both sides x and x, x and x, and you've got your rectangle measured 1 by x plus 1. They said that the area is total to 7. So the area of this plus this plus this equals 7. So the area of the 2 squares, you've got x squared plus x squared. So the area of this first one is x times x, so that's x squared. The area of the second one is x times x, which is x squared. The area of the third one would be one lot of x plus 1, which is x plus 1. So x plus 1. So you've got x squared plus x plus 1 would equal to 7. Simplify. You've got 2 lots of x squared, so that's 2x squared. You've got your 1x. You've got your 1. If we take away the 7, so chuck the 7 over the other side, that equals to 0. We've almost got it, we just need the 6. So we can simplify this bit to get 2x squared plus x minus 6 equals 0. So I'm just proving that this is correct. Solve the equations to find the length of each side of the square. So we've got to solve this quadratic. When we are solving this quadratic, you need to factorise it. To factorise it, we do 2 times 6, which is 12. You need the factors of 12. You don't need them all, but I like to write them all out. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4, which come together to make 1. We need 3 and 4. It needs a positive 1, so it needs to be plus 4, take away 3. So we rewrite it, but we split our 1x into 4 and 3. So we've got 2x squared plus 4x, take away 3x minus 6. We split it down the middle, factorise 1 half, factorise the other. So what goes into 2x squared and 4x? A 2 and an x. 2x times what is 2x squared? An x. 2x times what is 4x? A 2. Factorise the other half, so what goes into minus 3x and minus 6? Well, there's a minus in both of them. We've also 3 goes into both of them. Minus 3 times what is minus 3x? It would be x. Minus 3 times what is minus 6? We would need a positive 2. So we've got 2 brackets the same. That means one bracket is x plus 2, and the other bracket is what's out on the outside. So 2x minus 3. because obviously we're solving this, you want to know what x is to make 0. So the first bracket, what would x need to be to make 0? X would need to be minus 2, because minus 2 add 2 is 0. What would x need to be to make 0 in this one? It would need to be 3 over 2, or 1.5, because 2 lots of 1.5 take away 3 is 0. Now, in content of the question, we're looking for a length. Obviously, you can't have a negative length, so therefore x has to be 1.5. Are we in centimetres as well? No, we're in meters. Okay, so x is 1.5. Okay, the diagram shows a sketch of the graph y equals f of x. Lovely. We've got to sketch the graph of y equals f of x, take away 3 in brackets. Don't forget, when anything's in brackets, it means the opposite. When it's inside the brackets and we're taking away 3, it means we need to add 3. So we're moving it this way by 3. So you just literally just sketch it and put in your coordinates. So instead of 2 and 7, it's going to be 5 and 7, because I want to add 3 to my x. Instead of 5 and 0, it's going to be 8 and 0. And instead of minus 1 and 0, it's going to be 2 and 0. So it doesn't matter how fancy your graph is, it's just as long as you state these coordinates. Okay, so when it's inside the brackets, you do the opposite. So we're moving it along our x-axis by 3. Use the axis below to sketch of the graph of y equals cos of x plus 1. So you draw your cos graph and then you would add 1. So whatever cos would be, so this is the cos graph, which is not very nice indeed. So they would end up in 360. So we've got the middle is 180, would be 90, etc. As long as you label those two, you should be fine. But because it's plus 1, it means it goes up to 2 and down to minus 2. Okay, question 16. The triangle ABC is an isosceles triangle with ABC equal to ACB. So ABC, so this is equal to this. PQ are points that AB and AC are respectively, so that AP equals AQ, so this equals this. Prove that triangle AQB is congruent. When something's congruent, it means it needs to be the same, so like it's got two sides the same and an angle the same, then it's congruent. So you would first state that AB is obviously equal to AC, because we've got, I spelled because wrong, we've got an isosceles. So this side, AC, is obviously equal to AB, because it's an isosceles. AP, ooh, I put PP. AP equals AQ, and therefore the angle A is the common angle. So you've got two sides the same and two angles that are the same. So it's congruent, well, the one angle, congruent as you've got two sides and the included angle, so the middle angle, so next to those two sides, angle. Or you could just, I think you can just put side, angle, side. I think you can put SAS. I'm pretty sure you can. Okay, so it's congruent as two sides and the included angle are the same. So these two sides are the same, these two sides are the same, and that angle is the same, therefore they have to be congruent. Okay, simplify that, ooh, that looks nice, and state whether your answer is rational or irrational. It'll be rational if it doesn't have a surd on the bottom of the fraction. So take one step at a time. So I'm going to just take this one. So 5 root 3 squared. 5 lots of root 3, that would be the same as, well, 5 squared is 25, so it'd be 25 lots of 3, all of that squared. So I'm just taking the 5 outside and putting it back inside the surd by just squaring it, basically. So 3 lots of 25 is 75, so we've got 75 squared. When you square a square root, it obviously cancels out, so that'll just equal 75. Next bit, so this one, 2 lots of root 18 divided by root of 2. I'm going to do the same thing as well. I'm going to take this 2 outside and put it back inside by squaring it. So that would be 4 lots of 18. And we would still be over root of 2. Obviously, you could put that all in one root as well. So you could do 4 times 18 divided by 2, which is the square root of 36. And obviously the square root of 36 is 6. And then the bottom, root 32 times root 2 is the same as root 32 times root 2, which is the square root of 64, which is 8. So I've got 75 take away 6 over 8, because this one is 75, this one is 6, and this one is 8. It's definitely rational then, which is 69 over 8. Therefore, it's rational. It's rational because it doesn't have a third on the bottom. Okay, question 18. A game is played at a children's party involves throwing a ball into a bucket. Each child tries to get the ball into the bucket at the least number of throws. On each attempt, the probability that Sophia gets the ball in the bucket is 0.8. Each attempt is independent of any previous attempt, so it's always 0.8. Show that she is 5 times more likely to get the ball in the bucket on her first attempt than on her first successful throw on her second attempt. So if she got it in there first time, that would obviously be 0.8. If she got it in there on her second time, she would obviously need a lose and then a win. So we would do a loss of 0.2, and then she would need a win of 0.8, which is 0.16. They said it's 5 times more likely. 0.16 times 5 is 0.8. That's all you really need to do. That's quite an easy last question.